Ladies and gentlemen, here we go, section 2 of chapter 5. We are going to go from section 5 of chapter 4 and use that knowledge of alternate interior angles, alternate exterior angles, and corresponding angles, and use that knowledge and see what happens with those angles if something special happens to actually, as you see on the screen here with the essential question, prove lines are parallel. Now what you're going to need to do is, that's right, get out this graphic organizer that I gave you in class. Well, there it is, right there. So get that bad boy out, because we're going to be filling that thing in for sure. So let's do it. Let me show you how this works, and we're actually going to give you, I'm going to get you 6 theorems. There's really going to be 3 main ones that I'll tell you to start that we're going to use the majority of the time, but you got 6 ideas here to actually kind of show lines are parallel. You already know this about slope. We just did this in class 2. Slopes you could use, but we're not talking about slopes in this section. We're talking about pairs of angles and using those pairs of angles in a unique way to prove the lines are parallel. So let's do it. Here we go. So first let me set the stage for you and see what's going on here with this picture, this goofiness. You can draw it on the back of the graphic organizer if you want. But what I'm showing you is, it says if 2 lines are cut by a transversal. So you see EH, that's my transversal, and my 2 lines AB and DC are the ones that's being cut, if you will. What you see is it says such that, but dot, dot, dot. So I'm going to show you what happens if I take these 2 lines here, cut it by a transversal, where something actually is unique that happens. Now here's a scoop. If you look at angle BFG, I'll actually highlight it for you. That's this angle in there. That is nothing more than an interior angle. And if I look at FGC that I have labeled here already, it says 99 degrees. FGC is the angle here I'll label for you. So those 2 angles, that guy right there where my pointer is, and that guy right there, they are by definition alternate interior angles. And what I want you to notice is these 2 alternate interior angles are not congruent. Likewise, check out the slopes of AB and the slope of CD. Those slopes are not the same. What does that tell you? Oh, that's right, since the slopes aren't the same, therefore the lines aren't parallel. But watch this. As soon as I take these angles, I will take this one. As soon as I take these angles and see what I can do. Now watch this angle here. I'm going to make it the same exact as that. I'm going to make them congruent. So as I grab a hold of this point, I'll pull it up until I get 84.4. So 84.4, there we go. So as soon as I put it at 84.4, these alternate interior angles are now congruent. As soon as I made them congruent, did you notice this? Did you look? Bingo. Look at their slopes. They're exactly the same. Now watch this. Let me take this point and I'll move it 1 simple little tenth of a degree off. As soon as I move it 1/10 of a degree off, 84.6 degrees compared to 84.4, those angles are incongruent. And notice, the slopes aren't the same anymore. So that is a huge, huge deal. As soon as you get a pair of alternate interior angles exactly congruent, you know what? Let me make it something completely different. I'll put it down here at 69 point, let's make it 66.7. That means I need to make the other one 66.7. Now what I want you to notice is, as this number is going up, check out what's happening to the actual slopes here. Ready? 66.7. Look. 66.7, 66.7. Look at that. The slopes are exactly the same. So as soon as you have a pair of alternate interior angles congruent, bingo! That implies to you immediately that you got parallel lines. I love it. Okay, so let's get back to this thing. If you haven't, again, you probably already do, but get this thing out. Let me get, let's get some of these theorems going here. But I also want to show you what this is up here at the top as a little general, like, you know, oh, that's actually a true statement. So let's do that. Okay, so at the very top of your graphic organizer, you're going to see where it says, that's true. Well, here's the scoop. What I want you to write down is exactly what's on the screen. If 2 lines are actually cut by a transversal, how many angles will be formed? Well, if I just took, you can see it on the screen, there's my 2 lines, cut by a transversal, it actually creates not 1, not 2, not 3, 4, 5, 6, 7, it actually creates 8 total angles. And what's cool about it is, these angles comparatively, alternate interior, alternate exterior, corresponding, mean certain things. So that's the first thing. Now, on to the actual main meat and potatoes, if you will, of this. You're going to see all 5 of these theorems in the middle of your graphic organizer, guys, they start the same way. They all say, if 2 lines are cut by a transversal such that, bleh, something in here is true. If something is true, then you can conclude the 2 lines are parallel. And here, where it says theorem number on the left column, you would write theorem number 31. In the middle, where it says official theorem, it's the stuff written here in black. So 2 alternate interior angles are congruent. So I'd read this entire theorem. You can look in your book too if this isn't working right for you. It says if 2 lines are cut by a transversal such that 2 alternate interior angles are congruent, comma, then the 2 lines are parallel. That's the exact official whole entire theorem. But again, where it says official theorem in your little graphic organizer right here, you can just put what's in black. 2 alternate interior angles are congruent. Over here where it says shortcut, this is exactly, guys, what I'm going to have you, and you're going to see me write this in every 2-column proof. That's your shortcut right there that you can write. Instead of the entire huge theorem, just write that. Congruent alternate interior angles imply parallel lines. Congruent alternate interior angles imply parallel lines. Beautiful. So here's a quick picture. You can draw it there on the side or on the back if you want to, but if I wanted to prove that these 2 lines right here were parallel, what I'd have to do is either know, show, or prove through multiple steps that angles 3 and 8 are congruent. That would then mean the lines are parallel because congruent alternate interior angles imply parallel lines. Or I could show angle 2 and 5 because that's the other pair of alternate interior angles. They have to be congruent though, with the lines being, if they're going to be congruent, that makes the lines parallel. The lines are not parallel if the angles aren't congruent. It goes hand in hand. So there's your, I guess if you will, first major theorem of this. And I put a star next to that because that's a majorly important one. Here's the next one. Theorem number 32. If you have a pair of lines that are cut by a transversal such that 2 alternate exterior angles are congruent, there's your shortcut. Congruent alternate exterior angles imply parallel lines. So that's the actual shortcut that goes again over here to the actual right. Official theorems and stuff in black. Theorem number goes right there. Beautiful. You get the idea. So here's your picture. Hey, if I have a picture like this and I showed 1 and 8, no, sorry, 1 and 6, those dueling alligators, but ding, 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 za. If those guys were congruent, then that would imply to me that I'd be able to say, hey, that line right there and that line right there are parallel. By the way, there's your parallel symbols. You just put little angle arrow marks on it like that. Or if you wanted to show angle 7 and 4 were congruent, somehow, maybe through a couple multiple steps or it's given to you, great. That's a pair of alternate exterior angles. If they're congruent, that means the lines are parallel. Bam. Okay. Next line, the middle one in the actual graphic organizer. Theorem 33. Oh, yep, you guessed it. If you can show a pair of corresponding angles are congruent, then that means the actual lines are parallel. Here's your shortcut. Congruent corresponding angles imply parallel lines. Here's your picture. If you want to show that these lines are parallel, well, by golly, then here's a scoop. You can show 3 and 4 are congruent. That would mean the lines are parallel. You can maybe do 5 and 6. You could do 1 and 2. Or you could do 7 and 8. Either way, you pick a pair. You don't have to show all 4 pairs are congruent. You only need 1. 1 pair of corresponding angles implies parallel lines. Beautiful. That one right there, the alternate exterior angle one and the alternate interior. The first 3 that we just did, you need to put huge stars around those because those are the 3 guys that 99% of the time you are going to be using in 2-column proofs. Absolutely, absolutely the truth. 99% of the time. Could you use elements? You betcha. But for what we do in all intent and purposes, those are the 3 that you're going to use. Now, the next 2 still are ways that you can prove lines are parallel. Theorem 34. It's a little lengthier, so you might have to pause the video. But it says, if I have 2 interior angles on the same side of the transversal, notice though it doesn't say that they're congruent. No. It says that they're supplementary. That's a major, major thing. It says they're supplementary, not congruent. So same side of the transversal and sup. I just kind of told you the shortcut. Here's your shortcut. Interior angles on same side sup. Sounds like I'm rapping. Interior angles on same side sup. What's up? Yeah. They imply parallel lines. Interior angles on same side sup. That would mean we got one more. Theorem 35. If I have 2 exterior angles on the same side of the transversal, well then, by golly gee, Miss Molly, then those buddies imply parallel lines too. So again, it's not that the exterior angles on the same side are congruent. No. It says this. If exterior angles, 2 exterior angles on the same side are sup, then that means the lines are parallel. And here's your shortcut. You got it. It is another wrapping form, if you will, I guess. But it's like the other one. It just says exterior angles on same sides up. 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 Exterior angles on same sides up imply parallel lines. So there are your 5 ones that go in the middle right there. But again, the first 3 are the main ones that we're going to be using. And there is one more down here at the bottom. You got it. Theorem 36, that's going to allow you to prove lines parallel. And here's what it says. It says, if 2 coplanar lines are perpendicular to a third line, then they are parallel. What does that mean? If I have one particular line like this, and I have another particular line like that, I have two coplanar lines that are perpendicular to a third line. Change color. So 2 coplanar lines perpendicular to a third line. What does that mean? So if I draw this thing right here, that's perpendicular to that guy and perpendicular to that guy. So it says if 2 coplanar lines are perpendicular, change colors, are perpendicular to a third line. So that's the blue one, this one, and this one. They are perpendicular to a third line. Well, then that makes this guy, yep, parallel to that guy. That is correct. That's what this says. Then they, the blue lines, are parallel. Beautiful. So there you go. So commit these shortcut forms to memory because, yes, we're going to use these and master these in class. Pumped up. Big time. By the way, study these theorems because listen, if you study these theorems in section 2, I promise you section 3 is going to be a breeze, a snap, a flash in the wind. I can't think of any other analogies. It's just going to be really easy for you. You need to practice these. Later, we'll see you in class. Peace.